Hey everybody, it's lesson 18 with Miss Phoebus. We're writing function rules. Alright, so today the goal for the lesson is to be able to write a function that describes the relationship between two quantities. Using function notation, we're going to look at that from the aspect of a table and then also from the aspect of a word problem. And then I can define reasonable domain, which depends on a context. Again, it goes back to a problem, a story, or a mathematical situation for a function. Um, your standards, we're going to be using function notation to evaluate functions. We're going to give them domains, and then we're going to figure out what the range is for that function, and we're using that function notation, so make sure you're practicing that. Relate the domain of a function to its graph and where applicable to the quantitative relationship it describes. So this goes into the reasonable domain. If you look at the italicized part, it says, for example, if the function h of n gives a number of person hours it takes to assemble n engines in a factory, then the positive integers would be appropriate domain for the function. So that would mean that we would not have any negative engines. We might have 0 engines built. We wouldn't have half engine built. So it goes into that, the idea of discrete and continuous, what uh, types of domain values are going to be good for our situation. We also have another function that says, another standard that says write a function that describes a relationship between two quantities. These are going to be real world in context. Again, they're going to come from tables as well as from word problems. But we are just going to focus on linear functions. You are not ready to write quadratic or exponential functions yet. So we're just going to focus on linear. All right, so here we go. A function is a relationship that assigns exactly one output value for each input value. And for each input, there is only one corresponding output. So guys, this is big. You have to know a function. If I want it to be a function, for each input, there's only one output. And for each output, there is only one input. It's only going to work that way. So a function rule, such as c of p equals p squared plus 0.06p. So this is a function rule. Notice that it has the function notation, in this case c of p. And notice that if p is in the parentheses, p is the only variable that is being used in my equation. We're not going to write y equals. If you write y equals, I know you didn't watch this video. I'm going to be like, why didn't you watch video 18? Because you used y equals, and y equals is wrong right now. When I tell you to write a function rule, do not write y equals. You are going to write function notation. I'm going to be big on that. I'm going to count off points if you don't use the proper notation. So this function rule is an equation that describes a functional relationship. I want to see that function notation. I want you practicing that. All right, so here we go. Problem number 1. You are washing and drying clothes at a laundromat. The relationship between the number of loads and the cost is a function. We're going to write a function rule. That means it needs to be in function notation. We're going to start with the idea of, is this a discrete or a continuous function? So we're going to go back and review that a little bit. So remember that a continuous function allows you to use all the numbers, fractions included. So let's think about this. Could I do a negative load of laundry? I don't think so. I don't know what it would look like for the laundromat to owe me a number of loads. So I don't think negative numbers would work. Would 0 work? I could wash 0 loads of laundry. I should be paying nothing, though, when that happens. What about a fraction? What if I walk in and say, hey, I've got 3/4 of a load of laundry. I want to pay 3/4 of that $2.75. Do you think that's going to fly? I don't think so. I think they're going to be like, well, it's still going to be one load. You're still running the washing machine one time. So they're going to go ahead and count it as one. So anything, I mean, even if you walked in with one piece of clothing, it would be a fraction of a load, but it would still be load number 1. So this is going to be discrete. Fractions are not okay. Even though the money is in fractions, we wouldn't be paying at any point in time $3.15 because that doesn't make sense. with what our table says. So we wouldn't be paying a fraction of whatever cost is in there. So let's look at creating our function rules. Now, we're going to have to be very specific. Usually, like when you're turning in worksheets and stuff on paper, you can write things different ways. I'm going to have you be very specific just to kind of help keep things straight and organized. But just know that you can be a little bit different, and there will be a time to be a little bit different. We'll talk about that. I think it's example 3. But when you write this, you're going to write this as f of x equals, no y equals, don't be creative, f of x. Okay, so f of x equals, and what we need to do is we need to figure out the change. As x, the number of loads, is changing, what's changing in my cost? How is y changing? And that's where you're going to start. You're going to look at how is the cost changing. So it looks like I'm adding $2.75 each load of laundry. Okay, so because I'm adding that piece each time, it's multiple additions become multiplication. That's going to be our coefficient on our variables. So our function rule is going to look like 2.75 times x, or $2.75 times x. Now, you need to check this because sometimes you will start with an idea from your table, and even the first number or the first and second numbers will work out, but you need to be checking everything that's in this table. So what we're going to do is we're going to plug in 1. So f of 1 means that I plug in a 1 for x. 2.75 times 1 is $2.75. So that's what I have in my table. All right, let's plug in 2. 2.75 times 2 is $5.50. So yes, it matches what's in my table, so I'm looking good. But I need to do 3 and 4 because sometimes it can change. So let's look. F of 3, 2.75 times 3 is $8.25. And F of 4, $2.75 times 4 is 11. So they match the table. Now, these are things that you can plug into the calculator. And if you don't know how to access your TI-84 graphing calculator on your Chromebook, you need to contact me so I can walk you through it. You do have a graphing calculator like the ones I've been showing you in the lessons. All right, so we have written our function rule. We've checked to make sure that it is something that models our table, and we know that it is also a discrete function. So we're done. Let's look at number 2. All right, write a function rule for the relationship between the number of hours and the number of miles. So I have hours, 1, 2, 3, 4, total miles, 60, 120, 180, and 240. So the question is it discrete or continuous? Can my hours be in fractions? Would that be okay? I think that we could do 1.5 miles in this situation, or 1.5 hours, sorry, in this situation. It would work, and we can figure out how much we've driven. Could we have fractions of a mile? Are you allowed to go part of a mile? Yeah, that would work. So this would be a continuous function. All right, we do not have any guidelines for writing this, so we're going to start with f of x, not y equals, f of x equals. And I'm going to try to figure out how my total miles are changing. That's my y value, or my f of x value. So I'm adding 60, adding 60, adding 60. So that's going to be my coefficient on my variable. So f of x equals 60x. All right, let's check it. So 60 times 1 is 60. 60 times 2 is 120. 60 times 3 is 180. We're matching the table so far. 60 times 4 is 240. We've got it. We've got our function rule that models this table, models this situation. All right, let's look at number 3. Write a function rule for the relationship. Now, there is no context to this, none at all. Also, notice that there's n and c of n. So if you are given specific variables, you have to use them when you write. You can't make it up. You can't go back to f of x now. It is now giving you something to use. So you have to use it. Now, anytime that this table is not given any sort of situation or background or anything like that, it is automatically continuous, automatically. This would be something that you would plot the points, you would connect them with the line, you would be, done with that. All right, so let's try to figure out how the y values are changing. Oh, sorry, f of x, not f of x. We're not using f of x. We're changing that to c of n. Now we're going to see how our y values are changing, our c of n values. 5 to 8, you add 3. 8 to 11, you also add 3. 11 to 14, you also add 3. So, looks like we're adding 3 each time. So that's going to be our coefficient on the variable, and our variable is going to be n, not x. Whatever variable is inside these parentheses has to be the variable in that equation. So, let's check. Let's plug in 1. So 3 times 1 is 3. That's not what I got in my table. Okay, so to go from 3 to 5, I would need to add 2. So what I'm going to do is I'm going to experiment with this. I'm going to add 2 in my equation, and I'm going to check to see if it works. And then it has to work with all of them. If it doesn't work with all of them, then I've got to go back and rethink things. So 3 times 1 is 3. 3 plus 2 is 5. We're looking good there. 3 times 2 is 6. 6 plus 2 is 8. Okay. 3 times 3 is 9. 9 plus 2 is 11. Looking good. 3 times 4 is 12. 12 plus 2 is 14. So we have found our function rule. So sometimes, right off the bat, just like I didn't get it right off the bat, sometimes you have to add or even subtract something. But you should probably end up pretty close by when you do this plus 3 plus 3 plus 3. That multiplying by 3 should get you pretty close. And then you just have to figure out how you're going to get to that number. All right. So if they give you a variable and then, your c of n or whatever, you have to use it. If not, otherwise you use f of x. All right, let's look at number 4. Write a function rule for the relationship. Now this is, we're taking toothpicks and we're building little two-dimensional houses from those. So we're not going to be building half a house. We're not going to be breaking toothpicks. So this is going to be discrete. All right, this is going to be f of x because I do not have any other variable values given to me. And now let's see how the y values are changing. 6 to 11, add 5. 11 to 16, add 5. 16 to 21, add 5. So it looks like I'm adding 5 each time. So that's going to be the coefficient on my variable x. So I'm looking at f of x equals 5x. Let's try it. Let's plug it in. Let's check it out. So 5 times 1 is 5. But that's not what I got in my table. I have a 6. So I'm pretty close by. All I need to do to my 5 is add 1 to it. So let's add 1 to my function rule. Now that changes to 5 times 1 is 5 plus 1 is 6. Let's check the others. 5 times 2 is 10. 10 plus 1 is 11. 5 times 3 is 15. 15 plus 1 is 16. 5 times 4 is 20. 20 plus 1 is 21. All of these match what I have in my table. If they don't match, you have to reevaluate and go back and look at your function and see what changes could you make. All right, so we're doing pretty good. We are writing function rules. We are checking them by plugging things in. Now, let's talk about reasonable domain and range. Remember, functions can be discrete or continuous. Because of this, there may be some situations where we just can't plug in any x value or input. We have to be selective, so we have to go based off of what the situation is. We will clarify reasonableness by listing 3 or 4 domains that fit. All right, so the questions we're going to ask ourselves: are negative numbers okay? Do they make sense to the situation? Are fractions okay? Do they make sense? Does 0 work for the situation? If I'm paying for something and I go 0 hours to, am I going to get charged? That doesn't make sense. Now, when you go through and you do your homework, you're going to have parts like we just completed. They're going to be in 2 parts where you have to write the function rule, and then they give you a specific value to plug in, and I want to see your function notation. when you are doing these type, which I think is number 4 or 5 or 6, something like that, you are going to be instructed. In the examples I'm going to do, I'm going to show you that you can choose. But you're going to be instructed. I think one of them is like for the first 3 hours. So that would be hours 1, hours 2, hours 3. Or for the first 3 lines, 1, 2, 3. Just to give you a little bit of guidance. But we are going to talk about some other things to consider, especially these questions down here. All right, so Manuel has already sold $20 worth of tickets for the school play. He has N tickets left to sell at $2.50 per ticket. Write a function for the total amount collected from ticket sales. So he has N tickets. So that is the only variable that they gave us. So we're going to write this as f of n. Okay? And just remember, f stands for function. N is the variable that I'm going to use to write my function rule. Now, he already has $20 worth of tickets, so that's not going to be affected by the number of tickets he sells, other than it's going to make the cost go up, or not the cost, but the amount he's collected go up. And then the $2.50 per ticket, that needs to be with this variable because each ticket that he sells should be multiplied times $2.50. So we should have f of n equals $2.50 times n plus 20. If you have 20 plus 2.5n, that's the same thing. Now, can he sell negative tickets? I don't think so. I don't even know what that looks like. Could he sell 0 tickets? Absolutely. $20 would be the max that he would bring in. Could he sell half a ticket? That doesn't make sense. Okay, so you wouldn't sell half a ticket to somebody to go to the school play. So we are dealing with 0 and positive whole numbers. Positive whole numbers work here in our domain. So I picked 4 values just so that you can see that you do not have to always choose 1, 2, and 3. You can jump around. But when you write the range, you're going to go through and plug each of those values in. When I plug in 0 first, because it's written first, my range is going to be written first. And then when I plug in 5 second, my range for whatever the answer is going to be written second. So it has to go in the same order. So if I wanted to jump around and do 0 and then 20 and then 7 and then 5, that's fine. But I have to make sure my range that is associated with each of those numbers is in the same order. So let's look. Plug in 0. We already know that 0 plus 20 is 20. Plug in 5. We get $32.50. Plug in 7, we get $37.50. And plug in 20, we get $70. So each of these is a range, and I'm going to list them in the same order. And if you want to put dollar signs or units with them, you can. You do not have to, but it is something that you are allowed to do, and I wanted to just show you that. So 0 gets paired with 20, 5 with 32.50, 7 with 37.50, 20 with 70. And so the order matters there. And so I'm going to be watching for that. All right. A landfill has 50,000 tons of waste in it. Each month it accumulates an average of 424 more tons of waste. Write a function for the total amount of waste in the landfill. All right, so we have a function but no variables to describe it, so we're going to go straight with f of x. We start with 50,000 and we are adding 424 more tons every month. And month is going to have to be our variable x. So however many months we have, we're going to multiply that by the 424 and then add it to our 50,000. So this is the way that I wrote my equation, my function rule, f of x equals 50,000 plus 424x. If you write 424x plus 50,000, you are also correct. I chose some small numbers for my domain because I wanted to make sure that we had plenty of room to write our range down. So I chose 0, 1, 2, and 3. Negative numbers don't really, I mean, they could work here. It depends on how long this landfill has been around. Are we looking at how many tons it had, 20 months ago? We could possibly look at negative numbers, but that would be back in time before a certain starting time. Does it automatically start with 50,000 tons? I had no clue. Fractions probably would not be good here because each month it accumulates an average. So just because it has 424 tons of waste coming in doesn't mean halfway through the month it has half of that. It could be used as a predictive quality, but I would probably steer clear of fractions for right now. So I would pick 0 and positive numbers unless we were told that we could kind of go back in time and look. So let's plug in 0, 1, 2, and 3. So I'm going to plug in 0 and get 50,000. Plug in 1, get 50,424, and these are in tons. Plug in 2, get 50,848. And then plug in 3 and get 51,272. And in that order is how I write my range. Now you could have picked other values. It just kind of depends on the wording of the problem. And like I said, in the homework, you're going to be instructed to do it for like the first 3 hours or the first 3 lines of the newspaper. All right, number 7. And this is the last one. I want you, it doesn't say you try, but I want you to pause the video, see if you can figure out what the function is, and then come up with a reasonable domain. It may be different from mine, but it should be along the same lines of what's going on. All right, so because there are no variables in number 7 given to us, we're going to use f of x. And we know that she is borrowing $60, so that's going to put her in debt. She's going to owe $60 before she even makes any bread. So she's going to have a negative profit. She's going to charge her customers, so she's going to have income, money coming in of $1.50 per loaf of bread. So we don't know how many loaves of bread she is going to sell. So loaves of bread is going to be X. To get her income, she's going to be multiplying $1.50 times X, but then she's going to subtract that $60 off. So it's going to look like 1.5x minus 60. Now, she's not going to sell negative loaves of bread. She's not going to sell half a loaf of bread. It is possible, but usually when you sell things, you don't sell half of something unless you're in some sort of special circumstance. And if we were in a special circumstance, they would have told us. So we're going to assume she only sells whole loaves of bread for her domain. Now, don't be surprised when I plug in numbers to get a negative answer back out, because that's going to mean in your range, negative numbers mean that she's in debt. She has not paid off that $60 bread machine yet. So I picked 0, 20, 40, and 60 for my loaves of bread, and I wanted to do that so I could see if she, or how many loaves of bread she needed to sell in order to get out of debt. So those are the numbers I chose. If you chose 0, 1, 2, 3, if you chose other numbers, that's okay, just as long as they're not negatives and they're not fractions. So I'm going to plug in 0. F of 0 is negative 60. So she sells no loaves of bread. She's in the hole $60. If she sells 20 loaves of bread, she still owes $30. If she sells 40 loaves of bread, she owes $0. She has $0, I should say, as her profit. So this is what we call in business a break-even point, where she has paid off her debt, and everything after that is pure profit. So she has to sell 40 loaves of bread in order to pay off that bread machine. And then at 60 loaves of bread, she will make $30. And then everything after that is pure profit because she's already paid off her bread machine, assuming she doesn't have any other expenses. All right, so her range is negative 60, negative 30, 0, and 30. Remember, order matters here, and I'm going to be looking for that. All right, I will see you in the next video. Bye.